Now we're back to Godot docs, getting started step by step, and we're going to be creating our first project, creating our first script. There we go. In this lesson, we will code our first script to make the Godot icon turn in circles using GD script, like that. As mentioned in the introduction, they assume that we have programming foundations. We sure do. The equivalent C# code has been included in another tab for convenience. We'll see about that in a second. All right. Here's a C also to learn more about GD script and its keyword syntax and all this. We've got this GD script reference. This is in the manual down here. Way down in the manual. And then C also to learn more about C#. We can do that here, which is also in the manual. So they got a lot of stuff in this scripting part going on here. We've even got that, like the C++ stuff. Anyway, so yeah, they've got all that stuff. We'll get to that at some point when we need it, if we need it, when we need it, if we need it. All right. So the project setup. We're going to create a new project to start with a clean slate. Our project should contain one picture, the Godot icon, which is often used for prototyping in the community. Okay. So let's do that. Let's come over here to Godot and let's make a new one. Create. Let's call this spinner. It's not really spinning though. It's moving in a circle. Circle project, circle test, circle training circles. Circle. Okay. There we go. Create and edit. Boom. Did they want us to do extra stuff? I don't know. Anyway, let's go back over here. So it does that. We need to create a Sprite 2D node to display it in the game. The scene dock, we're going to click the other node button. We're going to press Control A, honestly, or in reality. And then we'll type Sprite 2D in the search bar to find it, and then we'll create it. And it'll be over here. All right, so let's do that real quick. So let's press Control A to pull this thing up. Let's say SPR, and that'll give us Sprite 2D right there. Create it, and we can see over here, it's right there, like it said over here. All right. So a 2D node needs a texture to display. In the inspector on the right, we can see that the texture property says empty. What? Inspector on the right. Inspector on the right. So this thing, if we look at it, okay, let's look at it now. What do you say? Yes, it does say empty. Okay. Let's go back. To display the Godot icon, we can click and drag the file icon.svg from the file system dock onto the texture slot. Okay, file system dock icon.svg. We'll come over here and we're talking about this over here and this. We'll drag it, click and drag over to this. Boom. And so we got an icon going on right here. They're going to say to put it in the middle. Let's just put it in the middle. Boom. Good enough. All right. Let's go back and see. So yeah, we did that. And we saw that in there. Right there. There it is. We can create 2D sprite nodes. Pardon me, sprite 2D nodes. Jeez. Automatically by dragging and dropping images on the viewport. Okay. Then we're going to click and we already did that. All right. Creating a new script. To create and attach a new script to our node, we're going to right click on Sprite 2D in the scene dock and select attach script. What did you say? Right click on Sprite 2D, attach script. Okay, that's what we'll do. Boom. Boom. Where you at? There it is. Boom. We should have read more. Never mind. Anyway, let's go. No, that's fine. That's fine. That's fine. So the attached node script window appears. It sure did. It allows us to select the script's language and file paths, pardon me, among other options. We're going to change the template field from node default to object empty to start with a clean file. Okay, so this thing right here. All right. We're going to leave the other options set to their default values and click the create button to create the script. What did you say? Okay, okay. Everything else default. So we're just going to change that. All right, so let's do that. Right now it's, well, it would have been on no default, but I rehearsed things. Anyway, man, I should have left. Well, there was no way for me to know. Anyway, so once you change it to object empty, it'll probably stay there. All right, so let's create it. Boom. All right. Let's go to the next part. C# script. We're not doing C#. The script workspace should appear with our new sprite2d.gd file open and the following line of code. Extends sprite2d. It does. And it's named that. How'd they know? How'd they know? Anyway, let's go back. Boom. Every GD script file is implicitly a class. Okay, does that just mean they're already classes? Okay, probably that's what that means. The extends keyword defines the class this script inherits or extends. The extends keyword. Okay, this keyword defines the class. So that's the name of the class that this script inherits or extends. Okay, so it extends it. What? Why wouldn't it have the word inherit? Never mind, it doesn't matter. Oh, what? Are these interchangeable? That's the point of saying that? Anyway, it doesn't matter. In this case, it's sprite2d, meaning our script will get access to all the properties and functions of the sprite2d node. Okay, including classes it extends like node2d, canvas, item, and node. We'll figure more out. We'll figure that out a lot more later, hopefully, probably. In GD script, if we omit the line with the extends keyword, our class will implicitly extend ref counted, which Godot uses to manage our application's memory. All right, so we're going to need to remember to do that. But you know, I mean, at some point we're going to forget. I wish we could see what happens if we did that. You know what? Wait, can we run this? Let me push F6. Later. Let's do it later. Let's do it later. Let's focus up. But will we ever be here again? Let's do a print hello world. How do we do that? Print. I don't know how to do that. All right. Wasn't it like print? What was the funk? Print. No. Hello. And then let's do this. And let's bring it down here. Let's say print. Does that work? Can we do print? Is that how we do it? Print hello world? Hello world? Wait, is this the first one? Should I not be spoiling it? Let's see if this works. I don't care. Let's press F6. Yeah, let's not spoil it. All right. Forget what I was doing. Let's go back and get back with the program. But what happens if we don't have this? Anyway, whatever. That sucks, but whatever. Anyway, inherited properties include the ones we can see in the inspector doc, like our node's texture. Okay? Inherited properties. Node's texture. This. So it's inherited filter and an inherited repeat. Okay. Note, by default, the inspector displays the node's properties in title case. The inspector node's properties in title case. What? I guess that's title case. Is that what this is? Title case? Inherent? I guess that's what's going on. Anyway, let's go. With capitalized words separated by a space. True, okay. In GD script code, these properties are in snake case. Okay, with lowercase words separated by an underscore. We can hover over any property's name in the inspector to see a description of its identifier in the code. Let's do that. Filter. Okay, you see property texture underscore filter. Okay, and we're not going to read that. Maybe later, not today. Here we go. So hello world. That's what we. Oh, what? Oh, I should have done this. This is funk in it, right? Is that what I was supposed to do? Funk in it? Maybe. I don't know. So our script currently does not do anything. Let's make it print the text hello world to the output bottom panel to get started. We're going to add the following code to our script. So this right here, let's get it. Let's bring it over here and then let's, there we go. Let's run it with an F6. Wait, let's let it tell us to do that. It's not going to tell us. Let's just push F6 and just press save. All right, great. Look, and it does that. Great. And then let's get rid of this and see what happens. I'm impatient, but I want to see. Nothing. Okay, so nothing happens. So it needs to be there. That's all. That's basically what we learned. There it goes. Awesome. Okay. Back to this. Okay, let's act like we didn't just run it. Let's break it down. The func keyword defines a new function named init. So func, and the new function is named init. All right. This is a special name for our class's constructor. So initialize. All right. The engine calls the initialize function, let's say, on every object or node upon creating it in memory. Init on every object or node upon created in memory if we define this function. What? What does that mean? Anyway, GDScript is an indent-based language. The tab at the start of the line says print. Pardon me, that says print is necessary for the code to work. What? Oh, the tab at the start. Yeah. We learned GDScript. Jeez. Where are we? If we omit it or don't indent the line correctly, the editor will highlight it in red and display the following error message: indented block expected. Yeah, we've seen this. We're going to save the scene as sprite 2D TSC in if we haven't already. Yeah, we did. And then press F6. Yeah, it makes us do that if you press F6. We're going to look at the output bottom panel that expands, and it should say hello world. Let's go and see. Well, it does. Yeah, look, it did it. Hold on, let's do it again. All right, why is this here? Is it because of the... What? I forgot. What is this? Sprite 2D. It's because of this texture. Oh, okay, yeah. Oh, yeah. I forgot. Ugh. Texture. So we can put anything we want there. I wonder what the limitations of texture are. We're going to have to get into all that later. Let's go forward. We're going to delete the init function, so we're only left with the extend sprite 2D. We can do that. Boink. See ya. Wouldn't want to be ya. All right, let's drop it down 2 because we know we're going to need to. All right. So next, turning around, it's time to make our node move and rotate. To do so, we're going to add 2 member variables to our script. The movement speed in pixels per second. Okay. And, oh yeah, the speed. Anyway, the movement speed in pixels per second and the angular speed in radians per second. We'll add the following after the extends sprite 2D line. Okay. So we'll have a var speed 400 and an angular speed pi. Okay. So let's go over here and let's just drop it like this. Boom. So let's come back over here and read some more, okay? So member variables sit near the top of the script after any extends lines, but before functions. True. Every node instance with this script attached to it will have its own copy of the speed and angular speed properties. Every node instance with this script attached to it will have this. Yeah, because it's in the script. Why is it so hard to read this when it's just common sense? Why does common sense take so many words? Anyway, but it's always like that, so no big deal. Where were we? Here? Yes. Angles in Godot work in radians by default. But we have built-in functions and properties available if we prefer to calculate angles in degrees instead. Yes, we know this. We did the GD script class. To move our icon, we need to update its position and rotate every frame in the game loop. We can use the process virtual function of the node class. If we define it in any class that extends the node class, like Sprite2D, Godot will call the function every frame and pass it an argument named delta. Let me back up. Godot will call the function every frame and pass it an argument named delta. The time elapsed since the last frame. That's what delta is. We know this. We already know this. Games work by rendering many images per second, each called a frame, and they do so in a loop. We measure the rate at which a game produces images in frames per second. Most games aim for 60 frames per second, although we might find figures like 30 FPS, on slower mobile devices, or 90 to 240 for virtual reality games. Okay. The engine and game developers do their best to update the game world and render images at a constant time interval, but there are always small variations in frame render times. All right. That's why the engine provides us with this delta time value, making our motion independent of our frame rate. Look, the only reason obviously I need some content, but the only real reason that I'm really doing this, other than the obvious fact that I need content, is that this, even though we already know it, repetition solidifies stuff. So there we go. Doesn't make it any less tedious though. At the bottom of the script, we're going to define the function, all right? Define this function. So let's just take this here and we'll go over that in a second. So let's drop it, boom, just like that. And we've done this before. Rotation plus equals angular speed times delta, right? So we know that's going to rotate this speed, because the delta is going to normalize the frame rate, and the angular speed is the angular speed we define right here. All right, so let's go back and talk about it. So the func keyword defines a new function just like before. After it, we have to write the function's name right here, and the arguments it takes. Actually, let's call it the parameter in parentheses. Right? So we got the parameter right there. The colon ends the definition right here. And then the indented blocks that follow are the function's content or instructions. So this is the contents. All right, we know this. Notice how process and init start with a leading underscore. Yes, we have noticed that. By convention, Godot's virtual functions, that is to say built-in functions we can override to communicate with the engine, or just built-in functions, right? Start with an underscore. So the built-in functions start with underscore. That's what they're saying here. The line inside the function rotation plus equals angular speed times delta increments our sprite's rotation every frame. True. Okay. Here, rotation is a property inherited from the class node2D, which sprite2D extends. It controls the rotation of our node and works with radians. Okay, great. So in the code editor, we can command click on Mac OS. And this is a tip, by the way, on any built-in property or function like position, rotation, or process to open the corresponding documentation in a new tab. Let's go prove that. So yeah, if we don't know what's going on with this one, if it starts with an underscore and it's built in, we can control click. And would you look at that? We've got everything we need right here. And you can see it used to be just Sprite 2D. Now it's Node. Let's no, cancel. I can't get rid of it though. Once it's there, it's there. I don't know how to get rid of it. Close. Okay, close. But yeah, again, control click. I said control click. Okay, there we go. I don't know what the problem was, but that's what happens. Anyway, let's go back to learning more. All right, so run the scene. Did we not even run the scene? My bad. Let's do an F6 and we can see, wow, there it goes, spinning. So it was on the screen and now it's spinning. Great. Looks like some progress, doesn't it? All right, so in C#, they can deal with that. So moving forward, let's now make the node move. We're going to add the following two lines inside the process function, ensuring the new lines are indented the same way the rotation plus angular speed times delta line was before them. Okay, anyway. So yeah, let's take this right here and let's drop it off in here like that. And then let's say home and drop and pull this one over and then get rid of line 12. And then let's set this up a little bit better because I don't like the looks of it. It looks stupid. Let's grab this, drag it here, and then grab let's bring it back one and grab these and put them next to each other. And that's a little more organized in my opinion. Let's run it with an F6. Why not? There it goes. There it goes. All right. So now let's go over the code on the web page. Boom. Pardon me. So as we already saw, the var keyword defines a new variable right there. All right. If we put it at the top of the script, it defines a property of the class. I'm not too sure what that means. Inside a function, it defines a local variable. It only exists within the function's scope. Yeah, so this is a local scope variable right now because it's inside of this function, right? It's not a global variable like these. We know that. Although they called it something different in that class. I forgot what they called it though. That's why it's pointless. Why try to change things when I don't even remember what he did. There we go. They did say something else though. I don't remember though. Local scope. Anyway, so we define a local variable named velocity, a 2D vector representing both direction and speed. Okay. Yes, we do. To make the node move forward, we start with the vector2 class's constant vector2.up. Vector2.up. Yeah, okay. A vector2 pointing up. Okay. And rotate it by calling the vector2 method rotated. Okay, so let's go. Actually, let's finish this. This expression, vector2.up.rotated rotation, is a vector pointing forward relative to our icon. Okay, multiplied by our speed property, it gives us a velocity we can use to move the node forward. Okay, anyway, over here, let's go look at it. So yeah, basically we're having the position be changed to velocity times delta every frame, right? That's basically what's going on here. And so when we go over here, we can see vector2 up rotated. Let's run it with an F6. And we can see it's going in the direction of the top side of the square, right? Up, basically. So let's kill that and let's come back over here. So let's come over here and let's see what else we could do. All right. So we got up right there. We also have some other words we could put in there instead of up. Axis X, axis Y, down from angle inf, left 1, right up 0, right? So let's throw right in there. How about that? So how about that? Oh, so just click it and then press enter. That's what I did. So let's run it again with a little F6. And we can see now the circle is going from the right, where the lead of the circle is the right side of it. And it would be the same for left, down. From angle would choose the angle. Like if we did 45 degrees, I wish we could just stop it. Oh yeah, we can watch. This, and then let's get rid of position. And let's do this. So if, let's do that again. So if we did it like from angle like 45 degrees, I'm pretty sure it would like choose this and it would like do the circle like an arrow, not like an arrow. Well, where this corner leads. Okay, let's see if we can try that. In fact, from angle, enter, and then we're going to put in here 45 for a 45 degree angle, and let's run it. And let's run it after we get this stuff back. Let me copy this. Hold on. Copy this back in time. Okay, back in time all the way to here. Double click right, paste it, run it. And we can see it's weird. It's what? It's keeping it's keeping the it's keeping this corner as the fulcrum, if that's the word. I don't remember if that's the word or not, but that's not what I thought it was going to do, but that's crazy. So if we do from angle, it does that. What if we do like this? I want to see what that is, because that's what it said earlier. No, it doesn't do it. It doesn't like that. Okay. So yeah. So that's what happens when we do from angle. So yeah, it gets a little crazy, but whatever. Let's put it back to up. All right. Boom. And run it one more time. And there we go. All right. So let's go back to the site. So we did this, we said this, and now we're here. So we add velocity plus delta to the node's position to move it. So yeah, that's what they're talking about here. Plus equals velocity times delta, right? So this equation times delta updates the position. All right. The position itself, pardon me, is a type of vector too. We know that. A built-in type in Godot representing a 2D vector. And when we run it, it does that. All right. So moving a node like that does not take into account colliding with walls or the floor. In our first 2D game, we're going to learn another approach to moving objects while detecting collisions. Okay. Our node currently moves by itself, and in the next part, listening to player input, we're going to use player input to control it. Okay. 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 And then here's the complete script here. We changed it up a little bit to make it look a little more organized. And then there's all this stuff here. The animation choppy, disabling desync. It's not applied to me. Mine looks good. But if you got any problems, there's like some, what are these things called? Comments. I didn't really go through all of them. Anyway, and we're not going to go through all of them. So let's go next. I said, let's go next. Or is the internet off? Are you serious? Are you serious? Whatever. Anyway, let's go. So we're going to be on, what was it? Listening to player input. Let's click the, wait, hold on. Step by step. Yeah. Listening to player input. All right. Let's see if it works again. Next. Come on. Come on. All right. So we're on the next listening to player input, and we'll see you next time.